Hello, my name is Hassan Ahmed and I'm a senior consultant at Dev6. Thanks for joining us today to view the Dev6 TV webinar broadcast of Angular versus React. Frameworks are ultimately there to provide a solid foundation of best practices in your code. Many lessons are encoded in the design decisions of these tools. When you choose to use a framework for your app, sound and well-studied engineering principles are partially implemented for you out of the box. Both Angular and React are frameworks that can be used to build enterprise-class JavaScript apps. They both solve the same sets of problems, however, they tackle them in different ways. And it's those differences that should decide which frameworks are best for a particular project. The topic of today's presentation is Angular and React. I always start off these presentations by just defining what the term single-page application means. So for people who have been developing web applications using front-end powered technologies, things like Flash and Flex in the past, and now these days Angular and React, the term single-page application was commonly used to refer to applications that are developed basically as one page in a web page, and the entire application runs inside of the client side, inside of some kind of container. So previously you used to need plugins to do this type of thing, but with the rise of modern JavaScript frameworks, we can do this with things like Angular and React. And there's a lot of other frameworks like this, Ember and Vue. So at Dev6, we're currently using these two. In this talk, we're going to kind of talk about why these two, how to compare these two frameworks, and how to decide which frameworks might fit your organization better than others. Some of the largest web applications in production today are built with Angular and React. They have a lot in common, but they also have certain differences. Both allow developers to work on different parts of a web application in parallel, so it allows multi-people teams to work together on different parts of the code base. And they also have certain standards that allow developers to learn the framework in different areas, become specialists in different parts of the framework, and contribute different areas of your application. So we'll dive a little bit deeper into that. Another major factor is that both of these frameworks are open source. So the contributions from the open source community have a huge impact on the viability of using these types of frameworks in enterprise web application development. I pulled together some Google Trends. Basically, the labels here are missing, but I've colored the labels here to match the colors of the frameworks used. So React here is in blue and Angular is in red. As you can see in the last couple of years, they've both been tracking very popularly, very close together. It used to be Angular dominating search results. React has just become increasingly important, and it's very close to Angular these days. So I'll give you a little bit of background about myself and why I am talking about this today. So I'm a senior consultant at Dev6, and I lead the Facebook Developer Circle for Toronto. So Dev6 is an enterprise JavaScript consulting company. So we build JavaScript applications for large-scale enterprises, applications that are used by companies that are servicing 40,000 cars a day, networks that power 60 million phones, applications that manage the inventory of global retailers. These kinds of large, heavyweight, heavy lifting types of applications that are being built to take advantage of web technologies are obviously going to need a good amount of JavaScript expertise. So that's what Dev6 provides. So because these applications tend to be business critical and very important to the functioning of a large enterprise, improving the performance and reliability of the business at this level has a huge impact on the entire organization. That's where we provide a lot of help and expertise to make these applications work really well across the different parts of the web. Dev6 also provides training and development for web technologies. So we develop courses in Angular and React, TypeScript, Node to help train teams and companies learn to use these technologies. And a little bit about the Developer Circle. So the Developer Circle is work that we started doing when we started working with Facebook. So with Facebook, we're running a program to train 10,000 people. So Facebook is trying to train 10,000 people, and the way that Dev6 is contributing is through developing a training program to train 100 trainers all over the world. And so through that work, we learned about Developer Circles, and Developer Circles is all about training people all over the world how to use the Facebook developer platform. So topics related to development, user experience, analytics, startups. It's all about building companies and technologies that are going to take advantage of the 2 billion monthly active user platform that the developer platform from Facebook gives you access to. So that's a little bit about background about me. Let's go back to this topic of front-end frameworks and Angular and React. So just before we get into how they're different, I'm going to talk a little bit about what these frameworks have in common. So frameworks are ultimately there to provide a solid foundation of best practices in your code. Many lessons are encoded in the design decisions of these tools. So sound and well-studied engineering principles are partially implemented for you out of the box. Both Angular and React can be used to build enterprise-class JavaScript apps. They both solve the same sets of problems, however they tackle them in different ways. And it's those differences that should decide which framework works best in a particular project. So I have things up here like component-based architecture, state management, client-side routing. These are kind of the basics that you would expect a JavaScript framework to give you. When you're going to go ahead and start developing a large enterprise application in JavaScript, you need to have a common language or a common set of problems that are being solved because you're going to have this in pretty much every application that you build. So let's kind of go through some of these core basics and compare and contrast, what's similar and what's different about how Angular and React handle each of these things. So let's talk a little bit about components. Components are classes. They provide abstraction for managing when a piece of user interface is initialized, updated, and destroyed. When you let the framework handle this feature for you, you obviously get a couple of benefits. In your code base, you don't get a whole bunch of code that's really coupled to the UI, to DOM, or to native UI. The performance updates in JavaScript, the performance impact of doing updates to the DOM poorly are really bad. The framework developers on the Angular core team and React core team implement very efficient algorithms for updating the DOM, and you don't have to worry about using the latest tips and tricks and techniques that are available for updating the DOM in an efficient way to get performance benefits when you change the parts of your application dynamically. Obviously, you also get a separation of concerns. Components kind of provide you a good way to create classes that have a single responsibility. They're dedicated to different distinct pieces of the UI. One of the big differences between the two frameworks in Angular and React is how data moves in and out of them. We're going to dive into some of how Angular and React design decisions with respect to components affect data flow. So one of the big differences here we'll see is that Angular's data flow is driven by a two-way data binding system, one-way and two-way, and React has a one-way data binding system. So we'll see, kind of highlight how the components work in both of these frameworks, what the impact is of using a framework that's driven by one-way data flow or using a framework that's driven by one-way or two-way. So I'm reading in the comments here, David from Montreal is asking about the popularity of Vue. So we are currently looking into Vue. In this topic, we're just going to focus on Angular and React. Vue is also certainly a framework to keep an eye on, but we're not going to get into it in this talk right now. Let's take a look at some code for a framework just to get started. Really, really simple. On the top, I have a small Hello World code snippet that explains what a component looks like in Angular, and the bottom is React. So both of these are small little pieces of UI. In the very top here in Angular, it's very abstract. We're just using TypeScript decorators. But you can see kind of similarities and differences already. The term component, let's look at how they're implemented. At the top, we have TypeScript. At the bottom, we have JSX. These are the two differences, these are the two major differences in file types that these components use. So at the very top, let's look at Angular using TypeScript. That syntax there with the @ is what we call a TypeScript decorator. So in the TypeScript decorator, we're providing metadata that's going to modify a JavaScript class called greet, and that metadata is going to turn this class into a component instance in Angular. The template over here is a metadata property. In this case, it's just a simple string. So you pass in the string. In this case, if our class is initialized, a property called name, the template can refer to that property using Angular's data binding syntax. We have a similar thing going on in the React world, and the code snippet on the bottom simple React component. One of the differences here is that we're using JavaScript. We're also using JSX. So that's why you see that funny syntax with the angle brackets embedded directly inside of our code. That little return hello one, the reason that works there is because it's not pure JavaScript here, it's JSX, so that allows you to embed XML directly into lines of into your JavaScript file. But we have a similar thing going on here. Instead of defining a template, React components are designed to work off of pure ES6. So you can just see at the top there, we're using extends React.component. So the React framework is going to provide a class that you have to extend to create an instance of a component. And then you override the render function. Instead of providing a template inside of your render function, you return some JSX that contains the actual template. The binding system is also a little bit different here. You can see we're referring to this thing called props. So this is related to the way that data flows in React. It's one-way data flow. But here in this very, very simple example, we can kind of see how the exact same feature, a piece of UI, maybe a string or a header tag, is generated using components. And you see the difference in philosophy between the two. So at the top, we have TypeScript. We're using TypeScript decorators, highly abstract level. At the bottom, React moves towards sticking to pure ES6, closer to traditional JavaScript. But at the end of the day, you have a class here that represents a piece of UI, a very, very simple string. You can go a little bit further. Obviously, if we were going to make a more complicated UI, then you would have more features available inside of your component. So Angular has this concept of lifecycle hooks. So lifecycle hooks are, again, implemented as a TypeScript feature. So you have these interfaces, and then you have to implement the functions that come with these interfaces. Things that handle the initialization, change detection, projection, destruction, and all these things are part of Angular-specific implementation of a component. So the lifecycle hooks are implemented through implementing interfaces. If we jump to React, we would see a similar thing going on. There are a bunch of lifecycle hooks that correspond to updates, deletes, adding the component to the page, removing the component to the page. They have slightly different names, but we're basically doing analogous things. The difference being here in the case of components, because we're sticking with ES6, we're not going to use some feature like TypeScript interfaces. We're just going to use traditional overrides, traditional ES6 overrides. So the component aspect of Angular and React, they're kind of doing the same things. Well, because Angular is driven by TypeScript, we use more TypeScript features. Because React is going with ES6, we use traditional JavaScript ES6 features, but we're basically accomplishing the same thing. So we can go a little bit further than that Hello World example and come back. So here's an example of an Angular component that's using lifecycle hooks. So we're using the implement keyword, implementing an interface that comes with the framework. And in this case, you now have to write a function that implements the on-init interface. The TypeScript compiler would tell you, oh, if you're implementing a class that implements the on-init interface, then I expect to see a function with an implementation there. And that's how you would be able to start customizing what your component is going to do in the initialization phase. Accomplishing the same thing in React doesn't require an interface. It's just using traditional inheritance that comes with ES6. So if you want to hook into the lifecycle hooks to deal with updating or mounting or unmounting a component, then you simply override directly inside of your subclass of component. Again, we're accomplishing the same thing here. We're dealing with the lifecycle hook of a class that corresponds to a piece of UI. Both frameworks give you a way to do it, but the philosophy that comes from TypeScript influences Angular's way of doing it. Philosophy that comes from React drives React towards traditional inheritance in ES6. Okay, so that's a little bit about components. That's just a quick summary. Let's talk a little bit about how data flows through these components. So once you start setting up the UI and you start setting up some properties, you start binding to things. Sorry, before you start binding to things, you understand a little bit about events. The next topic is going to be how do you get data to update correctly? So you can update the view by hooking into lifecycle hooks. But how do you actually wire up your data to components? Again, these are framework decisions. We have the same problem. We have to figure out how do we wire up the state of the classes to the actual UI without having to write a whole bunch of code to do this manually. So Angular's philosophy is driven by two-way data binding. It's something that Angular has had all along since version 1, and they ported it over to version 2 as well. React prefers to go with one-way data binding, and everything is designed around the concept of having data flow only in one state automatically, and the other way around always has to be done manually. So there's advantages and disadvantages to each one. So we'll go into a little bit of examples to see, what are the impacts when you use one framework or the other. So in Angular, things are driven by events. So with Angular, you have, because of two-way data binding, allowing you to automatically update from component to DOM and DOM to component, you have to write, there's less code that you will have to write to manually synchronize these things. Components don't have to worry about these things as long as you understand the syntax for binding things up. Whereas with React, half of the work is not done for you. One direction is going to be automatically re-rendered for you, but the other direction is not. So this will require you to write more boilerplate code in React, but the upside of that is that the model is a lot less complex mentally. So it requires you to think where your state is going to live, and the payoff of thinking about your JavaScript state and properties means that you'll be able to reason easier or more quickly about what your application is doing, because you don't have to understand what the framework does. You're just thinking about pure JavaScript. So let's give you some, a little bit more details here. What Angular does with its data binding system, it's got interpolation and property binding and one-way binding. These are the two ways to handle data flowing from the state of your components, or properties, functions, things that are in your class. When you want that to make its way to the view, you use interpolation, which is the curly brace syntax inside of a template, or one-way binding and things like that. So what this will mean is that at any point in your code, when your classes that represent a component are updated, the DOM will get updated for you. So it's very easy because you just wire up a few things in your template correctly. If you understand the way that those things are wired up, then you have to write very little code. You write basically no code to keep your classes and the UI in sync. The other direction, DOM to component, is, for example, when the user is clicking on buttons, entering text into input fields, and changing the state of the user interface. We can also have Angular implement this kind of stuff. So Angular does this through events. When you set up both of them together, you get two-way data binding. So this means that the user updates to a property to an input box. If that input box is bound to a data property, you don't have to write any code to manually update an input box when a property changes inside of a class, or the other way around, when a user changes an input box, you don't have to write any code that will update the property inside of the class. With React, we kind of don't do this. Angular uses a property or service pattern driven by singletons. With React, there's multiple different options. So React in general is a lot smaller of a framework. A lot of people compare the two frameworks by saying, Angular is like a full-blown MVC framework, whereas React is just a Vue framework. In some sense, that's true, because there's a lot of things that are not kind of part of a regular React app, and those features are provided to you by other libraries. So you would just pull in other libraries that handle things like state management, HTTP requests, and things like that, whereas with you use Angular, you have a whole bunch of things. So David is also asking to define immutable. We'll get a little bit into that. But immutable, what I mean by immutable, it means a piece of data cannot be modified. So modifying a particular piece of memory at runtime is prevented. And the only way to actually update the state of your application is to clone and write functions that are going to clone a piece of data and update the clone and work with that. Whereas with Angular, you can update data directly and working directly with traditional mutable programming patterns. So these are just kind of the defaults that the framework is going to give you if you start working with them. Let's go a little bit into detail here. So with Angular, your components are provided data through services. Services are implemented as singleton classes, and the idea is that if you have a whole bunch of components that are powered by a service, those components are free to update the data in a singleton. That means that your synchronization will be a lot simpler. If you know and make it a policy that all services which are shared by every component update the same instance, everybody else can see the changes that one component makes. With data binding, properties that Angular implements, data binding, zones, and change detection, these are all the techniques that Angular uses to automatically redraw the state of the components in the user interface when the state of the service changes. With React, we do things a little bit differently. In React, you're not really encouraged to create these large services that correspond to the application state for your entire application. With React, components have their own state, and so you think of state as something that's local. How you update the user interface of a particular component comes down to understanding for every single component what the state should be, and you have to maintain the state locally and pass it from parent to child if you want to share them in the hierarchy of states. So that will work up to a certain point. But once you start getting 40, 50 components on a page, manually maintaining the hierarchy of the components that are nested inside of each other gets really difficult. So there's a lot of different libraries that allow you to do things like this. There's one very popular one called Redux that kind of makes it easier to write code where components want to have their own local state, but your application also needs to keep things in sync globally. So this is where Redux comes into play. What Redux does is it creates a gigantic state object that represents the meta state of all of the components, and it gives you utility functions to provide the pieces of the state that only certain components need at a certain time. So Redux is actually a re-implementation of some ideas that came from another library that did something like this called Flux. There's Flux, Redux, Reactiflux, and all these things. Like I said before, with Angular, if you kind of go with Angular, there's only one way to do things, or one encouraged, supported, community-adopted way of doing things. With React, there's a competitor library for almost every type of feature that your applications can do. So Redux is popular, but it's by far not the only way of doing things. So in this talk, we'll talk a little bit about what Redux does. We don't have time to go make a whole talk about Redux, but the concepts behind it are not very complicated. So Flux was the architecture that was invented by Facebook to handle state management. The idea here is that you take the state for all of your UI components, consolidate them into one JSON file, and the idea is that components do not modify the global state directly. What they have to do is use these functions called reducers, which update the store. So they update a piece of the JSON that they care about in the global state by copying it and updating the copied version, and then assigning the updated version to the old version. So this encourages you to write more functional programming. So David is asking if Redux is more flexible than Flux. I wouldn't say that. I would just say that this is something that you have to actually compare Redux, Reactiflux, MobX, all of these state management libraries. I wouldn't say it's more flexible. Redux, just the ideas behind Redux are a lot simpler than what Flux is doing. Flux has more subtleties to deal with certain edge cases, whereas Redux simplifies things down to three concepts: just actions, reducers, and stores. These three pieces of information make up how state is managed in a large React application. If you happen to use Redux, you'd set up a store that contains all of the JSON for your entire application. You'd set up reducers that can update specific parts when a component needs to. And actions are the events that actually trigger state changes. These are the three basic concepts, and Redux just uses this over and over again to solve every type of problem. Johnny Lee is asking what my thoughts are about using Redux, RxJS, or NGRX for Angular. The RxJS stuff, kind of a different concern. RxJS is kind of driven by using observables. So there are ways that observables will help in dealing with state management, but it's not really necessary. There's kind of two different orthogonal concerns. So when you start dealing with reactive programming extensions in RxJS or competitive libraries like that, you have to start thinking about converting your events, asynchronous events, into streams. There are stream-based event managers or state managers, but I haven't actually used any of them in my React applications. We both use Redux. I will talk a little bit about using Redux in Angular. It's kind of one of the points that I'm going to get to a little bit later, so I'll come back to that point. Let's keep moving in the different aspects of Angular React before I come back to that point. So we talked a little bit about components. We talked a little bit about data binding. The next kind of area that I want to talk about that your JavaScript framework would have to provide for you are the issues related to layout and styling. So once you know how components work and how to manage the events inside of them, once you know how to get the data side of your components working and wired together, the other issue you have is actually making your views work. So you can wire up views, you can wire up data binding. How do you actually lay out and style the content inside of your views? So these days, web applications are expected to run on varying sizes of desktops, laptops, tablets, smartphones, smart TVs, smartwatches, even VR headsets. These are all places where web applications run these days. So a specific requirement that comes up in enterprise web application development is the concept of white labeling. So vendors can rebrand with custom styles, logos, color schemes, fonts, and things like that. So if you don't have a structured and well thought out way of dealing with things like layout and styling, you're going to end up rewriting lots of layout and styling code every time these kinds of requirements come up. So one of the advantages of using frameworks like Angular and React is that you can kind of come up with a strategy that will help you do things like, repurposing a UI for different platforms and for different brands. So some of the Angular specific things in this context, other than just traditional web styling and layout issues, Angular is pushing towards the use of Shadow DOM and view encapsulation. I'll explain a little bit more about what that means. React, kind of like how in the other topics before, React, there isn't one answer for how you deal with these kinds of things. There's a lot of different styling and layout solutions for React components. So we'll kind of go into a few different options that come up with React. We can kind of compare what the output is. Here's an example of setting up styling for a React, so for an Angular component. Very simple case, we just have a small template here. It's got some components inside of it. The simplest thing you can do here is set up some CSS files. You set that up with a style URL property inside of the metadata inside of the component decorator. And so here we can have styles that are specific to your component. One of the things about CSS, before you start using frameworks, is you have to carefully manage the namespaces in your CSS. Because you have a whole bunch of content, you have a whole bunch of elements in your templates, they have different classes, and as you add more and more content to your application, it becomes difficult to manage the names of all of the elements in all of the templates. We have some global templates, you have some local templates, they have custom styling. You end up getting naming collisions. So part one is just being able to create CSS files that are component specific. That'll help. But this doesn't solve the problem that CSS has with styles overwriting each other when you name them. It becomes a really difficult task if you have a 40-page application and you want to add your 41st page and you need to come up with new style names that don't clash with the other 40 names at some point. So this is where Shadow DOM comes in. Shadow DOM is a proposed standard, W3C, that allows DOM elements to have a subtree of DOM elements. And this kind of allows parts of the DOM to be encapsulated from other parts. This allows you to name things locally as if they were global properties without actually overwriting the global CSS styling of other properties. So you can kind of encapsulate components, the HTML, CSS, and JavaScript components into one sandbox without bleeding your styles into other components. So this is something that's enabled by default. And Shadow DOM is currently implemented by only Chrome. Google is hoping that the standard becomes adopted by all browsers. Angular has already moved forward and adopted Shadow DOM, and the way it does this is it creates specific identifiers for other browsers where the styles are generated for specific IDs at build time. So if you look at the styles, if you actually look at the content that gets generated by a style sheet, you'll see these IDs, these auto-generated IDs and numbers, underscores. That's because the pipeline of your Angular build when you're using Shadow DOM, which is on by default, If you're not in a browser that supports Shadow DOM, Angular will implement a virtual version of Shadow DOM for you by adding specific IDs, classes, to your templates at runtime. So this allows you to style an H3 tag inside of a component in one place and not overwrite the H3 tags in all the other components if they have the same class name. You can disable Shadow DOM if you want to. You can always go back to traditional CSS styling. If you do that, then you simply set your view encapsulation to none. If you only want browsers that natively support it, you can set it to native, but currently the default is emulated. So emulated means that it will work across all browsers. And in the long run, when this becomes adopted by all browsers, then emulated won't be necessary, and we can just depend on the native implementation of Shadow DOM. So that helps you kind of, other than all the other things that you have to deal with when you style web applications, this is kind of the only new thing that Angular adds for styling. Shadow DOM and view encapsulation allows you to kind of manage the styles for your components without bleeding into others. But there are a lot of different opinions on this topic, and not everybody agrees that Shadow DOM is the only way to do things. So that actually comes up in React. So if you look at React, they start off with just basic styling. But by default, React doesn't have any particular CSS solutions. You style your JSX with the style property, and the style property is just a JSON that corresponds exactly to regular styling. So this kind of leads to writing styles for your components, regular CSS styles. So it's very, very simple. You get small little inline styles. You're just writing CSS and JSON. You're attaching those to the style object in your JSX. So this is what you might do by default if you're starting off writing a small little React app that doesn't need a complicated style implementation. You'll start off with simple CSS. As you get more sophisticated, as your application becomes larger and larger, you'll probably find that this styling solution doesn't work. It gets very difficult to manage all of the styles, all the properties for all of your different components. You kind of want a more structured way to handle your styles. So we'll look at it to a few different libraries that help you do this. So JSS is an implementation of CSS and JSON. So there's a library called React JSS that allows you to write JSONs that have React-aware styling attached to them. The library is available on GitHub. There's a link on the slide there. Again, we'll upload a recording of the presentation that contains all this stuff. You don't have to worry about digging up all these links again. But the basic summary of React JSS is that it returns higher order components. So we'll wrap your components in higher order components. It'll inject CSS classes into the props property of your React application. So it just allows you to write these styles by exporting an injected style sheet. You can write your class without any style stuff embedded in it, and then use the utility function inject sheet to attach the styles to your component. So this will help. This will allow you to at least separate your styles into one separate JSON file, your component in another file if you need to, and then output a final component that combines the styles and your component, and that's what you'll actually use at runtime. So this is a starting point, but this is still not solving the problem of clashing CSS names. This just helps you structure something. There are more structured styling solutions as well. JSX style is another library, and so what this does is it allows you to inline CSS properties as if they were properties that were built into React. So instead of referring to CSS, you can start writing your style code directly into your JSX. Again, this kind of may look weird to some people that have been used to writing separate style sheets. One of the things that both Angular and React have kind of moved towards is making your styles smaller and more local, instead of global and defined for the entire application. The declarative style sheets that people got used to writing for large documents work for static content, but they're not easy to work with when you have dynamic applications that are changing the view and layout and size of things all the time. The nature of having an application that is more dynamic means that your styles have to be more dynamic as well. And that's why you'll see stuff in a lot of these libraries that kind of encourages you to do things that you think might be bad practices. They would be bad practices if this is how you style the static document. You wouldn't want your static document to have a whole bunch of metadata about how it's supposed to look. But because we're dealing with components here, these are not static documents. These are components that are going to change. So it's not inappropriate in this case to put style code with these components, because we've broken down these components, if we've done it correctly, into small, dedicated, isolated things. And it's not inappropriate to have them defined the way that they look and behave in one place. So JSX style will basically take CSS properties and provide them as React components. Here we're starting to get something closer into more localized components. Your components here in this case are not actually updating any global CSS. We're using CSS names, but we're actually writing styles with CSS names directly into our component. Okay, so that's one more topic. Another topic that we need to talk about here is routing. Routing is kind of the main concern you have when you build single-page front-end web applications. You have a whole bunch of views, and they're going to change driven based on when people click on buttons, change pages, change the URL. On a server-side application, this just corresponds to fetching a new resource on the server. But on a single-page front-end application, we're actually not fetching a new resource on the server. There's only an index.html, and all of the requests that leave out of the page have to stay on the index.html page. The router is usually something that has to be implemented in every single-page front-end framework. Angular has a certain router, and React has a whole bunch of different routers. Again, this is a pattern that we see over and over again when we compare the two frameworks. The Angular router is URL-driven, and it tries to provide a way to hook into how the URL maps to the application state. And so you're going to have things here that deal with links, clicking on links, navigating from button clicks and things like that. It's a very robust router that thinks about very web-driven, URL-driven routing. It's very web-focused. React has a whole bunch of different options. Because React is kind of a very small view library, it doesn't have to make a whole bunch of assumptions about how your state is managed, how your application is being navigated through. There's even frameworks like React Native where we're not even talking about a web app anymore. We're not even talking about a browser. So there are small libraries that are dedicated to each specific use case. The Angular router, I'm not going to do a whole example, but a small little snippet that explains what the router is doing. We have outlets that correspond to where the content on a page will actually show up. So if you look at a template, the router outlet is where the content from the router is actually going to show. So the small little template here shows a nav bar with two links at the top. We have some directives inside of the router module that allow you to route to a particular URL when somebody clicks on an anchor tag, for example. The router outlet will correspond to the actual component that got mapped to that. So it's component-driven. Route changes trigger new components, and they get attached to where the router outlet is. There's a few other files that would actually complete this example if we were looking at a real full Angular routing example, but just to fit this on the slide. The main idea of how routing works here is you set up URLs, you associate components with URLs, and then inside your template you have to write where you want your components to show up when that route is active. And then because it's also driven for the web, there's some extra directives that allow you to deal with the URL and link tags and things like that. So that's a really quick summary of Angular routing. React routing, there's a bunch of different libraries. So let's talk a little bit about the React router. So this is a very simple router that tries to provide something very similar to what the Angular router does. You set up components that are associated with URLs. So you can see if I go back and forth between these two slides, if you look at the app routes JSON, there's a very similar thing going on. App routes in Angular, it's a JSON that corresponds a URL to a component. The router component in React router is just a router, actually a component. There's a component called router, and inside of it you define for the properties that map a router URL to a component. Very, very simple, very simplified version, but basically it's a small little library that allows you to associate components with routes for a web-driven router. Sometimes you need to do something more complicated than that. So for example, if you have an application that's using Redux that has a whole bunch of states, and depending on which route is active, you may have different states associated with the URL. There's a library called React Router Redux. So this is currently in a separate repo, but because Redux is so popular, they're actually going to move this code into the React Router repo directly. So basically, if you're using Redux to manage your application state, you want React to do your routing, but the React Router and Redux aren't designed to talk to each other. They don't. You have to manually write code to sync the router code and your React component code. And so what this library will allow you to do is write Redux reducers and connectors that allow you to do automatic syncing with the browser history and things like that. So here in this case, you can be able to like click on different parts of your browser, navigation buttons, click on links. This library is going to provide components that hook these things up for you inside of a React store, so that when you switch between states, when your components are driven to particular React Redux stores, the router makes sure that the component has that store's data associated with it. So you have to combine the reducers with your router reducer, and that way Redux can fire the correct sequence of events to keep your data in sync with your route. Okay, so another major topic that we have to talk about when we compare these two frameworks is testing. Enterprise applications definitely need a way to support automated and end-to-end testing. So Angular has been driven through, since version 1, with extremely strong support for Karman for Jasmine through the Karma unit test runner and the Protractor end-to-end test runner. React, some people write their React tests with Jasmine. Some people use a library written by Facebook called Jest, and another famous setup is the Mocha Chai Enzyme setup. With every other feature that we've seen, Angular usually provides one single solution for every concern, and React usually has a whole bunch of different options for each one. So we're not going to go into too many examples there, but another similarity that we can kind of explain, see what these frameworks do. Another concern that both of these frameworks have to give you is the ability to run your code on multiple platforms. So obviously the web, your browsers are cross-platform, but what about beyond browser platform compatibility? So being web applications, obviously we can make our Angular applications or React applications progressive web applications. We can use hybrid mobile app frameworks like Cordova to wrap our web applications into native containers. Also, these days, there's frameworks like NativeScript and React Native that actually don't use the UI side of JavaScript at all. They don't use DOM, they don't use CSS, they use pure native UI, and you can use your JavaScript and component logic for native components using libraries like NativeScript and React Native. So both of these frameworks have solutions in both of these spaces. So kind of going back to that question earlier, I guess one of the points that I want to make is that these frameworks have enough shared concepts that there are times when you can actually mix and match these frameworks into the same project. So we mentioned before how Angular has the singleton service-driven pattern, and React is commonly used as Redux. There's no reason you couldn't use Redux concepts in Angular. In fact, there's a library that's very popular for doing that called ngRedux, which implements Redux-style state management for Angular applications. It's not a bad idea to use this if you can have architecture for your application that's driven by Redux-style immutable data and things like that. There are some advantages to doing that. Another concept is the React Native renderer. So the React Native renderer allows you to actually run your Angular application even if you're not using React Native inside of a React Native project. So this was a project that's become popular on GitHub. A few people have tried this out. You can use the native bridge that React Native provided and actually run an Angular app inside of it rather than using all the React libraries. And you can just use the rendering technology that is implemented in React Native for an Angular app. So these frameworks actually are, in some sense, compatible. People have kind of tried mixing these two frameworks together. Usually you don't have to do this, but it just says a lot about how these frameworks are so similar in some sense, but then also the differences allow you to kind of pick and choose which one's going to work for you. let me summarize really briefly what Dev6 and what we have found working through projects with both of these frameworks. What it boils down to for us is that your second Angular app, or your third Angular app, or your fifth Angular app is probably going to be pretty similar to your first Angular app. That is to say, the solutions that are provided by Angular work for many different types of problems, and you don't have to learn a new library each time you want to do HTTP, each time you want to do styling, each time you want to do testing, all of these concerns that come up with application development. Angular kind of has one solution for almost all of these problems. Your React application, however, they can be very different projects every single time because you can choose a different testing stack. You can choose a different router. You can choose a different state manager. You can try a two-way binding if you wanted to. You can do one-way data binding if you wanted to. So each time you do change one of these things in your React application, you're going to have a different aspect to your project. And there's pros and cons to doing things this way. One practical concern that enterprises often have, if you have a very customized specific tech stack, like you use a certain small set of libraries, it's going to be hard to hire and train people in your specific thing. Whereas Angular, there's one standardized solution to almost everything. You can pick up an Angular developer to be able to understand your Angular project really quickly. With React, it's kind of normal that every React developer has got experience with a lot of different libraries for these different concerns. They're going to have to understand the implications of each little library decision you made. So what are the pros and cons? They're both open source. They're both driven by large companies. So Facebook is powering React. Google is powering Angular. They have a lot of community support. There's a lot of open source libraries and projects that you can take advantage of when you start building applications like this. But what we find is that Angular is best suited for teams that prefer a single opinion that's going to be well-maintained, well-tested, peer-reviewed, and it addresses the common concerns of web application development. And it allows your teams to focus purely on functional requirements without having to reinvent the wheel on certain web application features. The trade-off for that is that you become dependent on a single framework. You don't have easy access to the lower-level implementation details. So when you have to implement some specific third-party library, it's a little bit harder. If you have to implement something at a lower layer, you have to think about how this third-party library is going to impact the Angular code that's doing a whole bunch of stuff for you already. Conversely, React is going to appeal to developers who prefer to have more choices and more techniques to architect things. So the extra flexibility means more complexity, and it means potentially having to re-implement certain solutions. But at the same time, it gives you that ability to be more custom and fit your solution a little bit better than what Angular could do in some cases. You may trade off, not having a canned solution for every single problem. In return, you're going to get the ability to customize very, very closely into sometimes very small or very large applications. You can choose, I don't need that kind of router here. I don't need that kind of view management in this application. So you get this variety that a lot of developers prefer to have sometimes. Sometimes you don't need a massive framework tool to build an application. So it depends on what your organization's development philosophy is. Both frameworks are implementing solutions to the same core concerns. They're still going with components. They're still implementing testing. They're still implementing data binding. They're still implementing state management. They're still implementing routing and things like that. So all of these concerns are available in both of these frameworks. And as the frontier of web applications continues to expand to more and more varied use cases and devices, what we expect of web applications keeps growing. So our opinion is that using tools that are future-friendly and reliable is increasingly important. So that's kind of a brief summary of Angular and React from Dev6's perspective.
We hope you enjoyed today's Dev6 TV broadcast on Angular versus React. If you'd like to learn more about this topic or would like to have some help from Dev6 around full-stack training or custom app development, please don't hesitate to reach out to us. Thanks very much.